We are going to study Science and Technology part 1st. But before that, do subscribe my channel and click the bell icon for notification. Chapter 4, Effects of Electric Current. Electromagnetic Induction. We have seen in the previous section that if we keep an electric conductor in a magnetic field such that the direction of the current flowing through the conductor is perpendicular to the magnetic field, then a force is exerted on the conductor. Because of this, the conductor moves. But if an electric conductor is moving in the magnetic field or the magnetic field around a stationary conductor is changing, what will happen? In order to find out an answer to this question, research was done by a great scientist, Michael Faraday. In the year 1831, Faraday showed that an electric current can be produced in a conductor with the help of moving magnet. Galvanometer. Galvanometer is a sensitive device which works on the same principle as that of an electric motor that we had studied earlier in the last video. Figure 4.14 shows us the image of galvanometer. We can make some electrical measurements with it. A coil is positioned between the pole pieces of a magnet in such a way that the pointer on the galvanometer dial is connected to it. When a small current, for example about 1 milliampere, flows through the coil will rotate. The rotation will be proportional to the current. The voltmeter and ammeter also works on the same principle. In galvanometer, the pointer deflects on both the sides of the zero mark, depending on the direction of the current. Thus, galvanometer helps us detect the presence of the current in the circuit and also its direction. Figure 4.15 shows us an activity which helps us to understand the working of galvanometer. Collect the material as shown in the figure. Complete the circuit by connecting the galvanometer. Keep the bar magnet erect in such a way that its north or south pole is just below the copper wire. Now, if the wire is kept moving from point A to B, the pointer of the galvanometer gets deflected. This is called Faraday's electromagnetic induction. Now, move the magnets with the wire fixed. The galvanometer pointer still gets deflected, indicating the change in the direction of the current. Now, what change is observed when the current in solenoid coil is switched on or off? Complete the circuit as shown in figure 4.16a. Discuss about the components and select them as required. In this experiment, if we open the plug key and make the current 0 in the coil. The pointer of the galvanometer deflects to a side, quickly comes back to 0. If the current in the coil is started again, the pointer again deflects to the other side and then turns quickly to 0. Now, when the electrical current is flowing through the solenoid coil and solenoid coil is displaced with respect to the coil, the current is still produced in the coil. That is, when current flows through the solenoid coil, a change in current in the coil produces the current indicated by the deflection in the galvanometer. Now perform two experiments as in figure 4.16b. When a current is passing through the solenoid coil and the coil is displaced. And also perform as in figure 4.16c when a current passing through the solenoid coil and the solenoid coil is displaced longitudinally with respect to the coil. What can be inferred from these two experiments? Well, even if the solenoid coil is kept stationary, a change in current in the solenoid coil produces a current in the coil. If the solenoid coil is moved towards or away from the coil, we see a deflection in the galvanometer. Also, the faster is the displacement of the solenoid, larger is the deflection of the galvanometer pointer. If the current in the solenoid coil is changed, a current is produced in the coil. Or if the solenoid coil is moved towards the coil, then also a current is produced in the coil, causing the deflection of the galvanometer. Faraday's law of induction. If a current is switched on or off in the solenoid coil, a current is induced in the coil. Such an induction is also observed when the current in the solenoid coil is increased or decreased. Current is induced in the coil when it moves aside from front of the solenoid. In this experiment, it is understood that whenever the number of magnetic lines of force passing through the coil changes, current is induced in the coil. This is known as Faraday's law of induction. The current produced in the coil is called the induced current. Thus, Faraday's law of induction is based on induced current. That is, when the current increases or decreases, or the direction of the coil changes, current is induced due to change in magnetic lines of force. Fleming's right hand thumb rule. We have learnt just now about induced current. So, when do you think the induced current in the electrical conductor such as coil be maximum? It will be maximum when the direction of motion of the electric conductor is perpendicular to the magnetic field. In order to show the direction of the induced current, Fleming's right hand rule is very useful. Take a look at figure 4.17 and do accordingly. Stretch the thumb, the index finger and the middle finger in such a way that they will be perpendicular to each other. In this position, the thumb indicates the direction of motion of the conductor. The index finger shows the direction of the magnetic field and the middle finger shows the direction of the induced current. This rule is known as Fleming's right hand rule. Alternating current AC and direct current DC. So far we have learned about a non-oscillatory current flowing in one direction in a circuit from the cell to the cell. Such a current is called direct current. As against current changing in magnitude and direction after equal intervals of time is called alternating current. Figure 4.18 shows alternating and direct current. The flow of AC and DC current are indicated by arrows in their respective circuit diagrams. Figure 4.19 indicates the graphical representation of alternating and direct current. The direct current can increase, can be stable or can reduce, but it is not oscillatory. This is shown graphically in the figure. Alternating current is oscillatory as shown in the graph. It increases to the maximum, then reduces to zero and increases to maximum in the other direction and again reduces to zero. In the figure, magnitudes like -1, -2 have been used to show the reverse direction. The oscillation of the alternating current occurs in a sinusoidal manner with time and hence is shown by the symbol as squiggly line. Direct current flows in one direction, but the alternating current flows in periodic manner in one cycle in forward and reverse direction. In India, in power stations generating electricity, one cycle changes in 1/50 second. That is, the frequency of AC is 50 Hz, 50 cycles per second. When the electric power is transmitted over a long distance, it is beneficial to have it in the AC form, as it results into minimum power loss during transmission. The home supply is of alternating current, that is AC. We have learned in the previous class about precautions to be taken while using electricity. Electric generator. We have seen the experiments based on electromagnetic induction. The current produced in those experiments was of very small magnitude. But the same principle can be harnessed for the use of mankind to produce large current. Here, mechanical energy is used to rotate the current carrying coil in a magnetic field around an axle, thereby producing electricity. Figure 4.20 shows us the construction of electric generator, where a copper wire coil ABCD is kept between two pole pieces of a magnet. The two ends of the coil are connected to the conducting wire rings R1 and R2 by carbon brushes. Both the rings are fixed to the axle, but there is a resistive coating in between the ring and the axle. The axle is rotated with the help of a machine from outside. Because of this, the coil ABCD starts rotating. The stationary carbon brushes B1 and B2 are connected to the galvanometer, which shows the direction of current in the circuit. Upon rotating the axle, the branch AB goes up and branch CD goes down. That is, the coil ABCD rotates clockwise. According to Fleming's right-hand rule, electric current is produced in the branches AB and CD in the direction A to B and C to D. Thus, the current flows in the direction A to B, B to C and C to D, as shown by the arrows in the figure. In the external circuit, the current flows from B2 to B1 through the galvanometer. If instead of one loop coil, a coil consisting of several turns is used, the current of magnitude several times flows. After the half rotation, the branch AB takes the place of branch CD, and the branch CD takes the position of branch AB. Therefore, the induced current goes as D to C, C to B and B to A. But the branch BA is always in contact with the brush B1 and branch DC is in contact with brush B2. Hence, in the external circuit, current flows from B1 to B2. That is, opposite to the previous half rotation. This repeats after every half rotation and alternating current is produced. This is what is called an AC generator. In the last video, we have learned about electric motor, and now just we learned about electric generator. The main difference between the two is that electric motor converts electrical energy into mechanical energy, while electric generator converts mechanical energy into electrical energy. Also, we just now studied the working of alternating current generator, that is AC generator. So, what will be required to make DC generator? The DC generator does work on DC current. The DC current, that is the direct current, does not change the direction in the external circuit. To achieve this, a split ring is fixed on the axle, like a split ring used in electric motor. Because of this arrangement, the branch of the coil going upward is always in contact with one brush, and the branch going downward is always in contact with the other brush. Hence, the current flows in one direction in the external circuit. This is why this generator is called DC generator. This is the end of our chapter. Do answer the questions given in your textbook. If you have any doubt regarding this chapter, do ask in the comment section below. Do like and share the video. Thank you.